What's going on, everybody? My name is Johnny Bandon and I'm the CEO and co-founder of Trepa Technologies. And in this video, we're going to cover Domain 1.4, the public key infrastructure. This is always such a fun topic to talk about because we really like to break it down and make it more simple. Because I know when I first started learning Security Plus, well, this is one of my hardest topics. Cryptography this, certificates that, public key infrastructure, certificate authorities, all these different acronyms, terms that obviously are in a very complex ecosystem. We try to make that ecosystem a little bit less complex. So let's go ahead and get started. Oh, just a reminder, this is for Security Plus SY0-701. So let's go ahead and get my face out of here and get started. So as you can see here, and let me get my OBS software out of their way, we have just a little quick diagram that I'm going to go over when discussing PKI. So let me go ahead and bring up my pen software so we can go ahead and get started. And I like to start off talking about PKI by talking about the internet and how we browse the web, right? So we know that when we type in a website in our web browser, we just get there. We don't really know what's going on behind the scenes. Is it secure? What is HTTP? What is even a uniform record or resource locator? What is URL? Well, we're not going to go over that, but we're going to go over how PKI does enable something called HTTPS, Hypertext Transfer Protocol Secure. That's what the S stands for. And it does that by enabling an encryption suite called SSL/TLS. Well, this encryption method that essentially creates sort of like a secure tunnel uses the public key infrastructure. And that public key infrastructure is based off asymmetric and symmetric cryptography. Asymmetric cryptography to first establish that secure connection, and then maybe a symmetric stream cipher like Cha-Cha or Salsa to actually encrypt the data in transit. Sometimes, right? So let's get into the mindset. Like we started up our small business, and now we're running an e-commerce site. And we start by building, let's say, a WordPress site because we want to use like WooCommerce or Shopify plugin on our WordPress site. So we have our website over here. Let's just say this is shop.com. And we notice that our users can only get to shop.com using HTTP. And now we want to make sure that those connections are secure. So we want to be able to use HTTPS. Well, what's the flow in that? So one, like to actually get into the nitty gritty, depending on what kind of like web service you're using, there may just be like an additional cost to do SSL, right? If you're to do this on the actual CLI, if you're like Linux machine, let's say you're running an Apache web server, or let's say you deploy WordPress on like Google Cloud using like Bitnami WordPress. To actually enable HTTPS, you have to generate what's called an SSL certificate. So that's going to be the language, right? And you'll probably go through like a playbook on the Linux like bash terminal going through generating the SSL certificate. So during that generation, a couple things are going to happen. One, your domain here, shop.com, is going to create a public key and a private key. These two keys, again, if you're watching our videos in order, we already covered this, are mathematically related. Meaning upon generation, there's no difference between the public and private key. We just designate one as public and the other as private. So that private key is going to be stored into our web server, whatever that may be. If that's like you're running a web server on a VPS off in the cloud somewhere, whether that's a VM instance or just a like you use something like Bluehost, whatever the case may be. It could be GoDaddy. That private key is saved in that server. Depending on what kind of enterprise you run, it could also be saved in something like a secure hardware security module, maybe a secure enclave. Main point being that private key does not get released to anyone. Now that public key is going to be sent off to our registration authority. What we do in our request to actually become part of this public key infrastructure so that these users, any users, can connect to us securely, is we are now requesting a certificate. So using this public key, we're going to generate a certificate signing request. that certificate signing request is going to have all of our information in it as well, including the public key. It's also going to have like other information like our domain name information and just other things like that, the location, maybe the language. When you go and generate an SSL cert, it runs you through this, okay? That certificate signing request is pretty much saying, hey, I want to get a validated cert from a certificate authority. That CSR, certificate signing request, gets sent off to an RA. That RA stands for a registration authority. That registration authority is going to provide verification services. So I'm going to write that out. Registration authority. So that's the first hop in what we call this chain of trust or this root of trust, okay? So that certificate signing request, again, has our public key in it. It goes to the registration authority, and it's going to verify us. Part of that verification is making sure that, like, we actually have a good domain. It's not blacklisted, things of that nature, okay? And this registration authority is then going to send that CSR off to what's called the intermediate CA, or the issuing certificate authority. So we'll call that the issuing certificate authority. Now, the certificate authority is just a company out there, okay? Like, I'm pretty sure Google's one, and when we get off this little diagram, we'll, like, look at what my certificate authority was for my Trepa Tech website, right? These are just what's called trusted providers, these certificate authorities. And they run these CA servers to issue and validate certificates for these websites like shop.com that want to participate in the public key infrastructure to do HTTPS. So that issuing certificate authority is going to be the CA that actually generates the X.905 certificate that's going to get sent back to shop.com. The issuing certificate authority gets its authority from what's called the root CA. So the root CA is like the holy grail, right? The root CA must sign the root certificate using its private key to say, hey, this is a validated certificate, okay? And it does that to the issuing certificate authority. And sometimes these servers could be, there could be a whole web server farm of them, right? Because there may be a lot of certificates that they have to issue and a lot of compute process and power, okay? So once that root CA gives its stamp of approval, say, yep, here's your certificate, it gets sent back to us, and now our public key is now, again, posted on our website or part of this certificate authority infrastructure and ecosystem, okay? So now, this root CA says, hey, in its long list, shop.com is good to go. They are a trusted website or web server, and you can trust their public key and their public certificate to do TLS and SSL connections. So now, when this user, we'll say this is Bob, opens up Chrome, and the reason I'm saying like an actual web browser is important. We're going to get into this. Once Bob opens up Chrome, hard-coded into the web browser from Google, right? That's the people that make Chrome, is trusted CAs. So let's say this is like, let's say Cloudflare. I don't even know actually if I think they're a CA. Cloudflare, Google Chrome is going to hard code in there saying, hey, yeah, we trust Cloudflare. So now when Bob goes to connect off to shop.com using HTTPS, now we can use that server's public key to encrypt the initial connection. And when that connection gets to shop.com, it can use its private key to decrypt. And then now they can use asymmetry to create those secret shared keys to now do symmetric encryption on that TLS data in transit connection. Now, if you don't know how asymmetry creates symmetric shared keys, go check out our previous videos. That in a nutshell is how PKI works. So now you may be wondering, well, okay, you said that this root CA gives a stamp of approval saying it's validated. And during that validation, it actually gives a time period. So let's say this X.509 certificate that I got issued is only valid till March 24. Well, now how will Bob know that? Well, it's in the actual certificate itself that it will expire, but how will it know if it's actually validated? Well, then we have these servers down here, like a CRL server, which stands for a Certificate Revocation List. Or we have other servers or services called OCSP, which stands for the Online Certificate Status Protocol. So your web browser here, or you can reach out and actually get the CRL list. You can download it, and you can also use OCSP, which is an actual service. It's a protocol where you can see if that digital or that X.509 certificate that's hosted on that website is still valid. So that in a nutshell is what PKI is. That is what we use PKI for, so that we can have secure web traffic all over, from any web server, between web server and client, web server and web browser. That is what PKI is for. So now let's go ahead and bring up my website, trepatech.com, and then we're also going to bring up a website where their certificate is used to do TLS encryption, but the Chrome web browser doesn't trust it. So let me go ahead and bring this, and I'm going to clear off our drawings there. So here we're on the Trepatech website. You can see our connection is secure. And here we see our actual X.509 certificate. So you can see it's issued to us, and then issued by GTS CA1P5, and that organization is just Google. So you can see that Google is what the root CA is. So if we actually, let's open up an incognito tab. We go to GTS root. So that's Google Trust Services. So that's Google's certificate authority. Now let's look at a website, a .mil site, that says not secure here. So does that mean it's not using HTTPS? Because that's what we see though. We see the S, and yes, it is doing TLS. So why is this not validated? We see the expiration date still good. We can look at the details, right? We see it has everything that an X.509 certificate needs to be able to do TLS, HTTPS connections and encryption. Well, why not? Why is it not secure? That is because Google Chrome, the actual organization Google Chrome that makes it, doesn't list the US government as a trusted provider. It doesn't say that this certificate is trusted. Now, why? I don't know. But that's what that means. So if you ever get this, it can mean a couple of different things. One, that the website that got its certificate, the certificate authority isn't trusted by your web browser, okay? That's all that means. It doesn't mean that it's not a good certificate authority. Like, I'm pretty sure the US government can be trusted at least for encryption, right? But for some reason, Google Chrome just doesn't have that hard-coded as one of the CAs that it trusts inherently, right? Just out of the box, right when we install Google Chrome. Okay, so now let's go ahead and move on. Here we can see kind of like a little cleaner diagram, but as you can see, it's the same thing. You see I just pretty much followed this flow when talking about it. That public key is part of that CSR. It goes to the RA, the registration authority. Then it goes to an intermediate or issuing certificate authority, which is given authority from the root CA. Okay, so now let's get into kind of the more nitty gritty. Let's actually go over some of this vocab. So let me go ahead and bring up my notes here. All right, so the CA, Certificate Authority. The Certificate Authority is a trusted entity that issues and manages digital certificates. It verifies the identity of entities requesting a certificate and issues them a certificate after confirming their identity. So that's what just a certificate authority is, period. Now the root CA. The root CA is the root of the certificate chain. It only needs to be online to sign the issuing or intermediate CA signing request. The intermediate CA. This acts as an intermediate between the root CA and computers or servers generating those certificate signing requests. So there can be a bunch of those issuing or intermediate CAs, and they're the ones that are actually going to deliver that digital certificate. And then the chain of trust. This ensures that each certificate between the root and the end user, whether that be a server or client, can be trusted. The RA. So the RA acts as a verifier for the CA, performing identity checks and authenticating users before they receive a certificate. So in some PKI systems, the RA functionality is integrated to the CA, so sometimes it's not a completely separate device or server. Now, probably in a large enterprise, like if you're Google, you might have some RAs, and the reason being, you just want to make sure that these domains that may be requesting a certificate to be used in HTTPS connections, you want to make sure they're not like blacklisted, okay? Or a well-known malicious domain. Then we have the different certificate types. So wildcard certificate. So wildcard certificates are used to secure a domain and its multiple subdomains with a single certificate. They're sometimes represented with an asterisk as part of the domain name. For example, the one we have on screen, *animelovers.net. And you can see the other subdomains here, which are each their own website. And we even do something similar. We have trepatech.com. And then when you buy our actual course, that's academy.trepatech.com. And then we have this extended validation. This is just something that was kind of left over from the old Security Plus, where it just says that it's even higher level of insurance. Then we have the subject alternative name. So this is a multi-domain certificate. It allows an organization that maybe has multiple domain names to be protected with a single certificate. So they're more versatile than wildcard certificates, as they can cover different domain names and not just subdomains. So how does that work? So a SAN certificate can include several different domain names in the certificate's subject alternative name field. So the actual X.509 certificate has that field, and you can input, let's say, for example, example.com, example.net, or example.org. And as you can see here, we have Dodge Trucks Fans Only Forum and Ford Trucks Fans Only Forum.com, maybe owned by the same guy, but it's using completely different domain names, but using a single certificate. Okay, so certificate usage, profiles, and templates. So client authentication. So instead of using a traditional username and password, clients, let's say you have an enterprise that's PKI integrated with your LDAP servers, like your Active Directory environments, you can use certificates, which kind of gives you a token-based authentication over a username and password. So like in the DoD, we have common access cards that we plug into CAC readers, and on that actual card is an X.509 certificate that we use for authentication along with the PIN. So server authentication. So this is used to authenticate legitimate servers to clients and encrypt the communication. So we can actually put on there like, hey, on your HTTP header, we want to make sure that you're actually authenticating to our server and you trust our certificate before we let you access, okay? So you could do that with HTTP headers, like enabling HSTS. Some more PKI concepts, so a trusted provider, also known as TSP in Europe. This is an entity that provides root certs or is a root CA and allows that to be part of that global chain of trust on the internet. So that's just a CA that is trusted globally and recognized by governments. So cross-certification. This is when two or more CAs need to trust each other. They will use their private keys to sign a certificate containing the public key of each other, and this is going to enable both CAs chains to trust each other. Breaking down some of the concepts we've already talked about. A certificate signing request. This is a message sent from the applicant, so your web server, right, to a registration authority or CA to apply for a digital identity to be part of the PKI. So let's talk about our lifecycle management now. So when we want to do PKI, especially in an enterprise environment, or we just want to maintain our web servers, we have to think about our lifecycle management. When will our digital certificates expire? Do we want to recreate our public and private keys ever? Do we have forward secrecy? Certificate pinning. So this protects an organization's users or customers from man-in-the-middle attacks. It works by embedding the server's public key into the website or client software. So instead of just using that digital certificate, we can actually embed our public key into our website as well for additional security. And then we're going to cover the CRL and OCSP. So not on here, I'm just going to talk about the CRL. So the CRL is a list of digital certificates that have been revoked before their scheduled expiration date or because of their scheduled expiration date. So how does CRLs work? So certificates can be revoked for various reasons, such as compromise of the private key, termination of employment. This is talking like enterprise PKI, right? Change in role. And then we have a list publication. So the issuing CA periodically publishes a CRL that contains the serial numbers of revoked certificates. So yes, in your X.509 certificate that you get issued, you actually have a serial number that's going to be tracked by the root CA. So when we have our CRL list, and I'm going to bring ours into view here, this is the serial number that's going to be used to easily identify that this certificate is no longer valid, okay? So checking CRLs. When an application, when we're talking our web browser, right, receives a digital certificate, it can check the CRL to ensure the certificate is not listed in there. And then if it is, it's not going to be trusted. So what are some of the challenges with CRL and why would we want to use OCSP over it? So the size and scalability. So let's say we've had a root CA that's been around since 1990. The CRL may have certificates that old, right? Making it a huge document or file, right? And then the timeliness. CRLs are updated at regular intervals, which means there can be a delay between the time a certificate is revoked and when the CRL is updated because it's a huge list, right? Now compare that to OCSP, the Online Certificate Status Protocol. OCSP is a more modern alternative to CRLs that allows applications to check the status of a specific digital certificate in real time. So instead of going through a whole CRL, the whole list, it just will verify a single certificate using the OCSP protocol, right? Or the Online Certificate Status Protocol. So it's quicker. It uses something called stapling. So this allows the client to trust the server certificate without contacting the CA for the updated CRL independently. So a lot quicker, okay? And then here we actually have an X.509 certificate for us to view and all the common attributes with it. And we can see this even when we take a look at our websites that we browse to. You can go look at their digital certificates. And they're in an X.509 format. So it's going to have all this pertinent information here. Sorry, my pen just sometimes goes crazy. Okay, now we're going to stop it right there because now we're going to get into PKI components in this next lecture, and I don't want the video going too long. But now what we're going to do is going to go ahead and bring up our quiz so we can actually verify that we have learned something about the public key infrastructure. So what I'm going to do is I'm going to pause this video, and then when we come back, we'll be in our Academy software doing our practice exam. All right, so now we're here at our practice exam software where we're going to have 3 questions going over public key infrastructure. So what we're going to do here is I'm going to speak aloud the question. We're going to pause the video, and then we're going to go ahead and answer. So question 1, what role does the Certificate Authority, CA, play in PKI? A, provides internet connectivity to organizations. B, it encrypts data stored on servers. C, it issues and manages digital certificates. Or D, it monitors network security breaches. So I'm going to go with C, it issues and manages digital certificates. So here, as you can see in our practice exam software, which if you come to our courses, you get over 1,000 practice questions, we have an explanation and the correct answer down here. So question 2, what is the primary purpose of public key infrastructure? A, to increase the speed of internet connections. B, to manage public and private encryption keys for digital communication. C, to store large amounts of data on cloud servers. Or D, to monitor and analyze network traffic. Obviously, we're going to go with B right here, to manage public and private encryption keys for digital communication. All right, third question I'm going to answer incorrectly. And I just want to show you that when you use our software and you answer incorrectly, it still gives you the correct answer. So question 3, what is the function of a digital certificate in PKI? I'm going to answer A, which is obviously not the right answer. The correct answer is B, and we see down here an explanation. So B, to serve as a digital passport, verifying the holder's identity and providing a public key. So explanation, a digital certificate in PKI acts like a digital passport or ID card. It contains the certificate holder's public key and identity information such as name, organization, and etc., which is digitally signed by the issuing certificate authority. Alright, I want to thank everyone for viewing, and please feel free to like and subscribe. And if you're an active duty, National Guard, or Reserve Soldier, click that link in the description below and see how you can use up to $4,000 a year in credentialing and certification assistance. That's right. If you're in the Army, doesn't matter, National Guard, Reserve, or active duty, you get $4,000 a year for credentialing assistance, where you can come to our live virtual training courses, you can get vouchers, ebooks, all for free by using your benefits. So click that link in the description below to find out more, and thank you for viewing. And do not forget to share.